at SPP. I like to think that we're like the air traffic control of the power grid. So we have members and customers, and all of them are actual utility companies. So companies like SWEPCO, which is part of AEP in Arkansas, and other companies in our region actually hire SPP to do things for them. So we are not for profit and we are independent. We make decisions and we are supposed to do that without showing partiality to any of our members. So we're kind of like their traffic control. We don't own the airplanes, we don't own the transmission lines or generators, but we do direct how they operate. We do direct how transmission lines are constructed. Again, we are not a utility. We are registered as a utility company, but we don't have any assets. All of our costs are just assessed to our members as a fee. So Eugene talked about our beginning, so I won't touch on that. But we are located in Little Rock. We have about 650 employees right now. So when I started at SPP in 2003, we had about 106 employees. So we've grown a lot since then. Most of our jobs are in IT, electrical engineering, operations, and then we have a financial settlements department that handles a few $1 billion of transactions a year to settle the money that's associated with all the directives that SPP gives. We operate 24/7. And we actually operate primary out of 2 locations. So we have a data center and an operations center in 2 locations, both in central Arkansas. And we split the load between those sites. So this is a copy of all of the organizations that include SPP and organizations similar to SPP. So you can see that most of the West and the Southeast United States does not have anybody directing their transmission. So that's still left in the individual utility companies in those areas. It's not really shown on this map, but there are 3 independent power grids in the United States and Canada. Everything to the west of Southwest Power Pool is in the Western grid. Southwest Power Pool and everything to the east is in the Eastern grid, except for Texas. Texas has its own grid, which got a little bit of notoriety in February when they were unable to keep the lights on due to the winter storm. But you can see there are 9 organizations that do, 10 if you count Alberta, that do what SPP does. So here's a visual representation of our traditional footprint. So we do offer more services to utilities to the west of us, but our full service suite is offered to the to this area. And you can see here a list of all the states that we touch. This is just an indication of transmission lines. So every transmission line that's greater than 100 kilovolts in our area is under our control. So we look out anywhere from 10 to 20 years to see where those lines are needed. We then direct the constructions of those lines and award, in some cases, award bids for the construction to those lines. But those lines are constructed by other utilities and owned by them. We just operate the lines after they're constructed. So one of the unique challenges of our footprint is if you look at the wind potential in the contiguous 48 states, and I guess Alaska and Hawaii are there as well, the dark purple areas indicate the areas that have the highest wind potential. So if you overlap our footprint in that area, you can tell that SPP has a lot of wind. So as the nation is looking toward more renewable sites of energy, you can tell that we have a lot to offer. We actually have more potential for energy than we have demand for energy in SPP. So our long-term strategy would be to figure out ways to try to get some of the wind potential produced and exported out of our footprint. We don't have a lot of solar in our footprint yet, but if you remember what I said about the different power grids, you can tell that most of the solar potential is in the Western grid, particularly in the Southwest area of the United States. But if you cut that out, what's left is, in terms of the East, is mostly concentrated in Southwest Power Pool. So we are beginning to see a huge uptick in solar. Wind and solar have unique challenges. We can tell a coal plant or a gas plant when to come off and on and when to go up and down. But wind and solar just operate depending on whether the sun's out or whether the wind's out. So that creates a lot of unique operational challenges for SPP and our member companies. So this is just a graph of the energy production for 2020. And for the first time ever in our footprint, most of our energy came from wind farms. So generally coal is our #1 producer with natural gas second. But over the last few years, wind has creeped up to be our #1 producer of energy. So this chart here just shows a trend of the sources of production over time. And you can see toward the right of the graph how the green bar with wind in it has overtaken everything else. So now on to our technology. So this is a snapshot. I think the snapshot's a couple years old, but I had it handy of what our technology footprint looks like. So you can tell we use a lot of physical and virtual servers. We have a lot of desktops and virtual desktops. So, you know, obviously with 650 employees, we have multiple desktops per employee. In our operations center, and a single employee may have anywhere from 4 to 6 virtual desktops open at the same time, all with data displays and information systems used to control the grid. We also have data circuits going not only all over our footprint, but also to our neighboring utilities that we use to exchange data. We exchange data with utilities as frequently as every 2 seconds, and generally every 10 seconds is the frequency of data exchange. So we're getting near real-time data from a big part of the eastern part, actually both eastern and western parts of the United States. We have over 160 different applications and systems, 528 databases, and obviously our network is pretty extensive, and we operate over 2 sites that hopefully operate so that if either site were to go down, or if an application in either site were to go down, that the other site would continue without any noticeable interruption. And last time I checked, we have about 5 petabytes of data in our between our databases and data warehouses. This is just an example of our environment stack. So for this, just remember that we've got this pretty much doubled across, at least from the production and QA perspectives. So we have our main data center in Little Rock and another data center in Maumelle. And our production network actually spans both data centers. So we have, think about our production as 2 different areas. We have what we call an ESP, or electronic security perimeter, where our data systems that operate the power grid are segregated. We have to closely monitor access and control what happens in the systems in that area. And then we have our other production networks that sit in the environment stack that in some cases actually interact with systems to the ESP. We have a quality assurance environment that is very close to production so that we can do performance testing and other testing before it goes into production. And then we have other testing environments. We have another test environment so our members can connect to us and make sure their systems are functional before they move up their environment stack. And then we have our own test environment for deploying releases and doing some smoke tests before going into QA. And of course, we have development environments. In some cases, we host development environments offsite as well. So we have one of our big vendors is in Redmond, Washington, and we have a development environment that we host and maintain for them as well. So just looking at our growth in the last 11 years, we had 600 servers in 2010. We're up to 2,800 now. We've obviously had a 10-fold increase in storage. We've had a huge increase in the number of databases, but IT staff has been fairly flat. You can see all this on this chart going all the way from 2007, which is when we started our first market. That's when we really first started directing generation for our member companies. We enhanced that dramatically in 2014, and you can see how our needs for data and for servers and databases has grown over time. And then you can see our staff at the bottom. Obviously, we've found ways to be more efficient. So we've been able to increase able to accommodate a dramatic increase of responsibilities with only a few incremental staff. Let's talk about how we responded to the pandemic. So just to give some timeline highlights, it's hard to believe that it's been so long, but in January of 2020, we have a pandemic plan, and our safety staff and environmental staff started looking at putting some specific indicators together for the COVID-19 pandemic. So we started that actually at the beginning of the year. In January, at the end of January, we started our incident response. So we have two different incident response structures. I'm going to talk about one of them quite a bit, but we have an incident command team, or the ICT, which is more of an informal group that gets together just to analyze the response, provide communications, and if things get to a certain point, we activate our incident command structure, which is a little more formal and has a more rigid thing. So we ended up activating the ICT in January. And then I won't go all over the timeline, but really in the middle of March, it became apparent that we needed to gear up our capability to work from home. So we're lucky that we already had, we had some things already in place. We actually had already circuits in-house that would double our internet bandwidth. We'd cut over to one in one of our locations, and we were getting ready to cut over to the other one. We also had VPN capability for most all of our employees, but we have concurrent licensing. So we began to think about, well, we probably need enough licensing to cover the majority of our workforce. March 13, we actually told employees if they felt more comfortable working from home to go ahead and do so. We began to accommodate voluntary work from home, but we thought that was going to be the end of it. And just 4 days later, we actually asked all of our employees who are able to do so to work from home. So, things were moving pretty rapidly in March of 2020. On March 27th, we actually took some actions to lock our campus down. So we prohibited any visitors on campus unless there was a business need for them to be there. We have 2 control centers where the staff rotate 24/7. In order to best protect them, we prohibited all staff from outside of those control centers from entering that, except for staff that we have for cleaning and disinfecting. So we actually shut and locked the gates for the first time in SPP's history on our campus, because our campus was normally fairly open to visitors, at least the business office areas, not so much the control centers, but we had everything locked down at that point. So we had some concerns about the control room staff obviously had to share space and had to even share equipment and facilities. We had disinfection procedures for that, but in October, we decided we probably needed a 3rd control room. That way, if someone was, if there was an infection in a control room, we could relocate the staff, or we could use that to further segregate staff through shift rotation. So actually implementing that control center was a big deal. We have a lot of regulatory requirements that apply to control centers. We had a training facility that was designed for people to come off campus and train on power systems that could accommodate 20, 30 or so people. We actually converted that to a 3rd control room, which required making sure we had locked doors, visitor logs, special routing equipment for the equipment in there, and we deployed that in October. We were able to offer employees vaccinations on site starting in March, and then on May we actually started our return to the office plan. So we have 4 phases of return to the office. The first 3 phases are all voluntary, except we do have limits on how many people can be in the office. So for phase 1 of our plan, the limit was 20%, which for us would be about 120 employees. As we asked people if they wanted to come back, we averaged about anywhere from 50 to 80 employees per day. And then we went to phase 2, which didn't actually increase the number of employees that wanted to be back in the office, but it did relax some of the restrictions we had in the office. So for phase 2, you could, phase 1, you had to wear a mask unless you were actually seated in your work area. Phase 2, you didn't have to wear a mask, but you did have to socially distance. But in August, as things started to look worse in the pandemic, we actually reverted back to phase 1, required everyone to wear masks in the office until October, which, obviously we resumed phase 2, and phase 3 is going to be in December. And then by January, we actually expect to go to work using a hybrid work plan. So some of our employees, obviously the 24/7 employees that work rotating shift, they don't have this option. But most of our office employees will have the option to work from home up to 50% of the time, and then team by team, they're going to work out how they're going to schedule their 50%. So just a little bit about our incident command structure. So the way decisions were made during the pandemic is we had a command area, which was our three officers that are over operations, and then our chief operating officer and our CEO. They jointly met and made decisions that things like, when do we move to the next phase? Should we commission a new control room? All those decisions bubbled up to the top. Below them, we had a safety team. In this case, the safety team made decisions about how we set up contact tracing for ill employees, how we track and report illnesses. So we did report aggregate numbers of the number of staff who were ill to all employees on our internal website. And if someone on staff became ill, they would then list anybody that they worked with that they came into contact with, and the safety team would make sure that anybody that had been contacted with anyone who was known to be infected was notified, and then we would ask them to quarantine for 2 weeks as well. So the quarantine meaning just not coming on campus, and then what they did with the rest of their quarantine was really up to them. They also put together some other policies related to the pandemic. The operations structure really consisted of mostly IT and operations staff, and they would do daily situational awareness reports and talk about needs that we needed for operations. So, for example, as we sent employees home, we probably had at the start 70% of our employees had laptops. We had to quickly arrange for all employees to have laptops. We ended up providing monitors and docking stations for employees to take home to help them work from home better. So those needs were identified by operations, and then the other teams below them actually would take appropriate actions to meet those needs. So I'll just call out the planning team. The planning team put together plans for how we return to work, how we commissioned the third site, how we met all the regulatory requirements for doing that. So the teams below that really supported the operations and command teams. So just talking about some challenges associated with being the pandemic. I already mentioned that our internet bandwidth, we were fortunate that we had already doubled it. Then we also deployed VPN. That went a lot more smoothly than it could have. So we had most people productive within 24 hours of our decision to send everyone home. We did have to make some tweaks to our online desktop backups. So normally backups are made continuously for all of our endpoints, but we had to be more strategic about how we did that when people were connected over VPN. A lot of times their home network might be the bottleneck in that case. Our ICS structure was heavily reliant on in-person meetings. So normally we would be in a war room for the ICS and discussing face-to-face, but we quickly had to convert where we did that virtually. We use a tool called Atlassian Confluence, which as far as this response was a very good tool for us to collaborate in terms of documentation, meeting notes, action items, and things like that. That was all facilitated with Confluence at some point. So our IT staff were very familiar with Confluence, but the rest of the company became very familiar with it throughout the course of the pandemic. So when we talk about our 150 so utility company members, we have a lot of meetings with our members to help drive policy and procedures for SPP. Most of those were held in person across our footprint and also in Dallas. Excuse me. And we obviously had to quickly get them used to meeting in person. So we did not have virtual meetings that often. And when we did, they were audio only. So we decided that they'd be more engaging if we were able to do audio and video. So we had to quickly ramp up the capability to offer that, and then make sure everyone in these meetings was comfortable with the capability. So that consisted of us doing training during the first portion of meetings, setting up ways that people could know how to ask questions and how to get heard. And that went fairly well well, but it was a lot of work. We also at that point had a lot of fraud. We would have people register for meetings and dial in, and we couldn't figure out what the goal was. And it turned out that they were dialing in from international numbers that were running up huge phone tolls for us. So we ended up having to put in procedures to vet people who registered for the meetings to make sure they looked legitimate. And we thought we had some settings in our tools to restrict international calls, and that didn't work the way that we were told it worked. And so there was a lot of things we had to do to get the virtual meetings worked out. And then obviously I already mentioned that we have 24/7 staff working in close quarters. So we tried to keep them isolated, and obviously they're kind of the bread and butter of operations. We need them. So we were trying to make sure they stayed well, and that worked fairly well as far as the infection rate among the staff. So we did have to get laptops and additional displays, laptops for a few employees, and we did offer additional displays for all employees. And we were lucky. I think we made those decisions fairly early on in the pandemic. Not long after we procured, 600 laptops, those were getting a little bit harder to find, but we were at least making decisions fast enough. We were able to get stuff in before we really saw supply constraints. Now there were some applications that really required a fast network connection for employees. A couple of engineering applications, a couple of accounting applications really expected that you'd have a full network connection. So in those cases, we actually configured virtual consoles. So those virtual consoles were on site and had very fast connectivity to those applications. And employees would then remotely log in from home to the virtual consoles that would then log into the applications. The bandwidth requirement for operating a virtual console was much, much lower than actually connecting directly to the application. So that was our workaround in the few instances we had for employees that really had connected from their endpoint directly to high bandwidth workstations. Obviously, we wanted to know what was up with staff. So we wanted to know, is staff, are they sick? Are they at home because they're choosing to work from home? In future phases, if they were planning to come into the office, could they let us know what their plans were? So our IT staff developed a management reporting tool where supervisors could go in and fill out that daily for each of their employees, and that would actually bubble up to reports for HR. IT was able to stand that application up in less than 2 days, and then we expanded it to meet the other needs. So that was a big success for us. Obviously, when you're connected from home, we're starting to be a little concerned on how people's home networks could impact the security of SPP. So we tried to educate employees on how to make stuff as secure as possible on their home networks. And we also made sure our VPN was configured. So the only way you could interact with SPP systems was on a machine that was VPN'd in. We don't have what's called split tunneling, which means if you're VPN to SPP, 100% of your network connectivity goes through SPP. Even if you're on a home network, your device is essentially invisible on your home network at that point. Some of the challenges with that is if we have a staff meeting, suddenly we have 600 employees connected from home on VPN looking at a video feed from SPP, even if that's hosted over the internet. So we had to ask employees to log off a VPN before participating in any big activities that we knew would tax our bandwidth. Also over cybersecurity, it was fairly common for us to have security intelligence sharing meetings. Most of those meetings, some of those meetings are classified. So we have several staff at SPP that hold security clearances. And the only way you can really get classified information is to be within a facility cleared for classified information. So really in that event, we stopped getting classified briefings for quite a while during the pandemic. So we didn't have any way to get that information. But in some other areas that were outside the classified space, especially we work with our peers in other RTOs, other transmission operators. We were able to deploy some encrypted chat clients so that we could actually talk about security issues that we were seeing in real time and have that be somewhat secure. So we do exchange a lot of information among the industry and get a lot of information, and a lot of that was improved during the pandemic. And then on-campus support. So in addition to our 24/7 operations staff, we had facility staff that maintained our facilities, made sure everything was cleaned and disinfected. Because we had locked down the campus, and we intend to leave it that way, we installed information systems that helped with visitor management, including allowing visitors to be pre-registered. And right now, when employees are in the office, they actually go to our visitor management system, which is some kiosks near our entrances, and check in and out of that system so that we know who's on campus every day for contact tracing purposes. So looking forward, I mentioned we're already looking at a hybrid meeting schedule. So staff will have the option to work from home at least 50% of the time. They have to work with the supervisor. We're hoping the supervisors can be flexible with employees to help meet some of the employees' needs, but we're not dictating to the supervisors how they do that. So the supervisors, if they want all of their employees in the office on a given day for their staff meetings, they can do that. Or if they want to just evenly distribute employees throughout the week in the office, they can do that as well. Our meetings, most of our meetings were in person and required a lot of travel. So now we've decided that our goal for all stakeholder meetings is 50-50. So we're going to cut travel for our staff and for the members that participate in meetings in half, and expect every committee that meets to meet half the time virtually and half the time in person. So we're hoping to balance those in-person interactions. I heard someone talk about before we started this morning about how, with Zoom meetings, people just get on and get off. We want to have in-person interaction and build some relationships, but we also want to leverage the technology to save everyone's time and money as well. So that's where the permanent reduction in travel is expected to come from. So with that, that's all I could think of about how we were impacted by the pandemic from a technology perspective, but I'll be happy to answer questions as there's time to do so.
Sam, this is Jerry Adams. I run the Arkansas Research Alliance. Barbara Sugg just came on our board. Had a lot of experience at Axiom, but I just have to acknowledge what a tremendous presentation that was. I mean, you had mission critical technology layered on the pandemic, physical access distributed. I also serve on the Winrock board that has about 1,000 employees. Theirs not mission critical, but they've gone through this analysis about home versus office versus hybrid. And I think it's the world going forward. So you displayed a kind of a great choreography on minute by minute over this last year and a half. So excellent presentation.
Thank you.
You mentioned that there were some unique challenges to solar and wind. Could you tell us a little bit about that? What kind of challenges?
Well, okay. So, one of the interesting things about electricity is you can't really store it. So, if a lot of people get home at the end of their workday and go home and flip their lights on, and they all get home around 5:30, we have a huge increase in demand at 5:30 every day. We're really good at predicting what that increase is going to be, and we pre-position generators to meet those kinds of changes in demand. With wind and solar, you don't have any options there. I shouldn't say that. You certainly can't tell when to pick up. It's free, so you're generally going to take as much wind generation as you can get because it's the cheapest thing we've got. But when you have different needs for electricity demand, you can't really count on wind to pick up. Now, we're also very good at forecasting how much wind there's going to be. We have so much of it that even if we miss the forecast on individual wind farms, when you add it all up, it's pretty accurate. But again, we have to keep on fossil fuel units to really adapt to the changes that wind has. Solar, you would think that solar would be less predictable than wind because when the sun's going to be out. but you just don't know. You could have a large solar farm that, maybe gets scattered cloud cover over a portion of that farm. And so solar turns out to be much harder to predict. So if the demand for energy is the same and you start losing 20% of your solar resources, you have to quickly ramp up fossil fuel units to pick that up. And you don't necessarily know when you have to do that. So what we would then have to do is have fossil fuel units powered on, connected to the grid, and then back down to the bottom so that they are capable of moving up to meet those kinds of drops in demand. Surprisingly, we don't have to do that very much for wind, but for solar, it's just a big challenge. So some cases, even with wind right now, there are times we get so much wind, we actually tell it not to generate, even though it's free. We say we just can't handle that generation because we have to have enough other types of generation to be able to keep the lights on reliably. And we'll be in that situation with solar. But the more adaptive that we can make our system, the more free-ish electricity we can take, and that not only reduces costs for all the utility companies and ultimately their members or their customers, it also helps reduce greenhouse gas emissions and other environmental emissions. So, the ticket to cleaner energy is being able to accommodate as much wind and solar as possible, and that's something that obviously a lot of people are concerned about.
Hey, Sam, with the change of obviously the world and so forth, did from a security perspective, which you obviously addressed to some degree more from the inside, but how about from the outside? Was there an increase during the pandemic, or has there been in people trying to, I guess, essentially attack the grid that you guys support so well? Was there a change there, or did that get better or worse?
The things are getting more complicated and worse. I don't know that the pandemic actually is responsible for any of it. Ransomware is something that we get more and more worried about. I don't know if you all heard about the Colonial Pipeline incident that took a fuel pipeline out for the Southeast for quite a while. That was ransomware. We know a lot of local companies in Central Arkansas have been impacted by ransomware. But we think that's just a general trend and not necessarily related to the pandemic. But security threats, most of them are tied to organized crime, right? There's usually money that people are wanting to get out of this kind of thing, are just going up in general. So we're having to be prepared for that. The pandemic, though, provides more challenges in organizing the information and having opportunities to work with, with insecurity, it's very collaborative. Even people who might be competitors on some level are willing to talk openly about their security posture in order to learn from each other. And those opportunities are just not as prevalent during a pandemic as they otherwise would be. So that's kind of where we're seeing it. But fortunately, we're not seeing any dramatic increase in attacks. I did mention that we had WebEx fraud, which we had never dealt with before. And we had called our provider when we first started seeing it. Our provider said, "Yeah, you're fine." And then we got a bill for like $40,000 the next month. And fortunately, they acknowledged it was their mistake and waived the $40,000 in charges. Because I kept telling, as we were seeing all these weird names and stuff pop up on our meetings are open mostly. So anybody can join. And so we were seeing all these weird things going on. I'm like, there's got to be a financial angle to this. People aren't doing this. There are people who do things just to be disruptive, especially when it comes to energy policy, because people like Greenpeace and other may be disruptive to help bring attention to climate change and things like that. But I'm like, most of the time it's money. Most time if people are investing so much time, there's a financial angle to it. And so that was the biggest thing we saw during the pandemic, was that WebEx fraud.
Hey, Sam, this is Srinivas. Good to see you after a long time, man.
Yeah, it's been a while.
Yeah. Hey, can you talk about the snowstorm that happened during the pandemic and any lessons learned from there, especially with the wind and solar being impacted a lot?
Yeah, well, so yeah, I can. If you ever want to have me back, we've got some materials we can present on that. But just in a nutshell, we saw that the wind and solar, that time of year, we don't expect a lot of performance out of those kinds of resources. So the wind actually performed more than we expected it to for that time of year. Most of the problem for that came from natural gas resources. So there were really two problems with the storm, it being so cold so far south. So a lot of the power plants, say south of Kansas, like starting in Oklahoma and going into Texas and somewhat going from Arkansas down to Louisiana, they didn't invest on equipment to keep those power plants going when it gets extremely cold. And similarly, a lot of the natural gas production facilities, most of which are concentrated in Texas and Louisiana, did not winterize the production of natural gas, which is the number one fuel that we need during those peak times. And so we either had resources that couldn't come on, or generators that couldn't come on because they were frozen up, or because their fuel supply, they couldn't get it because it was frozen up. And that was really the big root cause of the winter storm event. And that's why Texas, being its own power producer and also being, having a grid where they're very limited in what they can exchange outside of Texas, they really took the brunt of that. We were fortunate. We would have had a lot worse, even though we did put customers in the dark. We would have been a lot worse, but we were able to import 6,000 megawatts from the East because the East wasn't having as many problems. So because we had more import capability than Texas did, we didn't have nearly as much trouble. So that's in a nutshell what happened there with the winter event. And we're still working through that. We still a lot of the generators that did perform got underpaid because of our rules, and we're trying to figure out how to fix that. So the consequences of that event for getting resolved are going to take probably 5 years. Hopefully, we've got a lot of stuff in place for this winter, but to get it fully resolved, it's going to be a 5-year deal.
Yeah, great to hear how you guys handled that situation.
Thank you. That was also the PR side of it went really well, and I attribute that to having a smart communications team, and Barbara and Lanny, our CEO and COO, are also very savvy communicators. So another reason I think it went better for us in Texas is we were out there and we were being open and honest with people about what was really going on. I'm not saying Texas wasn't being honest, but they were just much more rigid in their communications, and they came across as being aloof.
Mm-hmm.
So I don't know how much more time we have, but Sam, I had another question for you. Thinking forward in the future, and I don't know if we have time to go into it because I'm definitely not an electrical engineer, but I find it interesting the way you said you can't really like store the energy, so I'm obviously not very knowledgeable in how the whole grid works and all that stuff. I'm very fascinated with it, but I'm curious, are there things that y'all are doing, or do you know about people in that space to innovate? I'm thinking of things like, obviously Tesla's done a great job from the standpoint of innovating on batteries for a car situation, not necessarily in a situation where you're dealing with like megawatts and massive amounts of energy. But I'm curious because I think there could be some unlocks there. Again, my limited knowledge around, like you said, solar or wind, where you've got some extra production and you're saying you can't store it. So I'm curious about, like, have there been teams or people? Obviously they have, but I'm wondering where that space is or if there's any innovation happening there.
Yeah, that's such a cool question. Yeah, we've been looking into that. First of all, there is wholesale level storage where you can put these huge batteries out in the field, and they can store electricity and then release electricity back. For every megawatt you inject into storage, you get much less than a megawatt out. I'm not sure how much the efficiency is these days, but let's say it's half. So that's okay, but it's just, there's a lot of investment to get the infrastructure for storage into place, and then it's not very efficient once it's there. But there is some coming in, and also to make to help reduce climate emissions. That's probably the business case for that sort of thing is looking more and more attractive. They're getting better and better at doing that. But some of the more compelling cases, Ford Motor Companies is really, if you study them, they're doing an amazing job. So they've got the F-150 Lightning that supposedly, if you install the right equipment, could power your home in a power outage for up to 3 days, right? So if you imagine that being, Ford producing the #1 sold vehicle in the United States, and if they can get people on that bandwagon, they're preparing to offer that to utilities at scale. So that Ford's going to be knocking on the utilities' doors and say, "Hey, I've got 500 megawatts of generation." And if you're a customer and you plug your vehicle in at night, let's say it takes 5 or 6 hours to fully charge. If the electric utility can get some value out of that, and it takes you 7.5 hours instead of 6 hours to charge, you're not going to mind so much. And there could be a lot of value that either you as a customer get or your utility gets out of that. So as the electrification of vehicles moves forward, I think that's going to be a really intriguing proposition. And so that's, and Ford is really, Tesla's doing it more on an individual scale, and Ford is already working to do that at a utility scale. So that's pretty exciting.
Does that mean that you plug your truck in and the truck outputs like, maybe we can't, don't have time to get into detail, but I'm curious, what is that like, actually putting power on the grid versus taking it off, or doing both?
Yeah,
or?
I mean, on the first level is maybe at least offsetting some of the consumer's use. So if you're consuming 800 kilowatts of power at your house, and your truck provides part of that, we see that as an 800 kilowatt benefit. But yeah, in the extreme case, it can actually put power into the grid itself. So, and if you've got enough trucks out there that are being managed by the same information system, then you've got something that's really valuable. So I think that'll be the future. I wonder how quick it'll be here, but it's exciting to see people already working on it.
That's crazy. Thank you.
Fantastic presentation, Sam. I think we're going to have to cut it off. I think we could ask questions all day long. I've got a long list, but we certainly appreciate you coming, and it's been a very, very enlightening presentation.
Well, thank you. I'm glad to be here, and hope to see many of you again soon.
Yes, absolutely.